to our next Algebra 2 concept is over logarithms. Now let's start with what we know about powers. Ignore the fact that we're talking about logarithms. Let's just look at this equation. 2 squared equals 4, and 2 to the third power equals 8. So what does that look like for this, however? 2 to what power gives us 6? This is defining x using a logarithm. Since we do not know 2 to what power gives us 6, we can use a logarithm. And we write that as this. So notice what's happened. The x, which is the power, now goes in front, equals, and we write log. Now what's the base here? Well, the base is 2, so that comes down, and now we do log base 2 of 6. So the power becomes what we're trying to find, which is x. So this is x equals log base 6. And all you can do there is just plug it in the calculator, actually. But, definition of a logarithm with base b. If b and y are positive real integers, and b cannot be 1, the logarithm of y with base b is denoted by log of y base b, or log base b of y, and it looks like this, equals x. If x represents the power, b is the base, and y is what it's equal to. You would read this as log base b of y. This definition tells you that the equations, such as these, are the same. The first is in logarithmic form. The second is in exponential form. All right, so let's look at these first examples. In A. Now remember, we're going to start with the base. The base is 2, so we do 2 to the fourth power equals 16. And as you can see here, that's how we write it in exponential form. So we start with the base, 4 to the 0 power equals 1. Start with the base, 12 to the first power equals 12. Base 1/4 to the negative 1 power equals 4. And you can see the answers that we just got are here. These are exponential forms, and these are all in logarithmic forms. Now in example 2, rewriting exponential equations. Now you've done this before. 5 squared equals 25. Easy stuff. But remember, we always start with log. Log, and then we do the base. Well, the base here is 5. So log base 5 of, we go to the other side, 25, equals always the power. And here are the rest. Log base 10 of 0.1 equals negative 1. Log base 8 of 4 equals 2/3. And log base 6 of 1 2/16 equals negative 3. Now, the best thing is that you can actually evaluate logs in your calculator. If we evaluate log 8, seriously, you just plug in log 8, it gives you a number, you round it. Approximately 0.903. Natural log of 0.3, bam, right there, negative 1.2, so on. So we're going to evaluate each logarithm. Now once again, you can use a calculator. But log base 4 of 64, we want to know equals x. So that's where we look at it this way. The base is 4, so we start with 4 to what power gives us 64? Well, 4 to what power gives us 64? Here it is. The answer is 3. We go to the next one. 5 to what power equals, that'd be 2/10 or 1/5. Well, that's going to be negative 1. 1/5 to what power gives us 125? Well, it's going to have to be to the third power, but then we have to flip it, so it's going to be negative 3. And lastly, 36 to what power gives us 6? Well, so we have to take the square root, which means it's the 1/2 power. Now, graphing them honestly is just plugging into a calculator, but understanding what you're doing. So we want to graph f of x equals log base 3 of x. So the first thing we're going to do is take the exponential form. So here's our base, 3 to the x. So that means our inverse function is g of x equals 3 to the x power. Easy. We plug in random values. 3 to the negative halves power is 1/9. 3 to the negative first power is 1/3, and so on. That's represented here. Now, we know, or you don't know, but we know, that the reflecting of, you're always going to reflect over y equals x. If you reflect over y equals x, you get the inverse function. So this right here is your function. Now you probably could also just plug this in your calculator or Desmos or whatever and get this logarithmic function. But this right here is the exponential function. We always reflect it over the y equals x. That gives us the logarithmic function. The reflections of each other. Reflections. So now we're going to look at common logarithms. Now common logarithms are going to be base 10. So base 10, they look like this. I don't know what that is. Let's get rid of that. A common logarithm is base 10. A natural logarithm is a logarithm with base e. It looks like this. Log base 10 of x equals log of x. Log base e of x equals natural log of x. Really confusing, I know. Now, so far, all you've been doing is just rewriting them from logarithmic form to exponential form and vice versa. But now we're going to take a closer look. We're going to take a look at part B and C, which illustrates two special logarithm values that you should learn to recognize. So, as soon as I find it here we go. We're going to let b be a positive real number such that b is not 1. The base cannot be 1. So this is log base b of 1 if we get 0. That's anything to the power of 0 is 1. That means a logarithm of 1. And a logarithm of b with base b. That means they're the same. Now, when we use inverse properties, by the definition of a logarithm, it follows that logarithm functions, so here's one function named g of x, equals log base b of x, is the inverse of the exponential function. Remember, inverse is like inverse operations. Adding is the opposite of subtracting. Taking the square root of something is the same as squaring it. So this is really confusing though. G of f of x. So that means we took f of x right here. We plugged it in right there for x because we're plugging in f of x in g of x. So that means log base b, and we take the x out and plug that in. Now notice what happens. All of this cancels. You are just left with x. The same thing is true if you plug in one to the other. If I take g of x and plug it into f of x, that means if I take g of x, plug all of this in for x, that means I have b to the power of log base b of x. All of that cancels, and you are left with just x. So, if you wanted to simplify this, 10 to the log 4. Now that means that there's a base 10 here. That means all of this cancels. Cancels. You are just left with 4. Next one. We have log base 5 of 25 to the x. Well, we have to make the bases the same here. So we have to make 25 into 5. So we could write that as log base 5 and then 5 squared, which means 5 to the 2x. That means the log and the both 5s, they cancel. You are left with 2x. Weird, I know. All right, now when you graph exponential functions and logarithmic functions, remember they're inverses of each other, completely opposite inverses. So let's just quickly ignore all this gobbledygook here. Notice that, like for example, the blue is exponential growth. That's just all it is an exponential growth. Blue is exponential decay. To get the logarithmic function, you just reflect it over the x or y equals x line. Y equals x line. It's always the same. But notice, exponential decay, reflected, gives you a logarithmic function. Exponential growth here, reflected, gives you a logarithmic function. So let's go over the logistics here. The graph of f of x equals log base b of x, that's logarithmic form, is shown below when b is greater than 1. Remember, b is greater than 1 means exponential growth. And when b is between 0 and 1, that's exponential decay. Because f of x, huge, major, whoop, whoop, because these two are inverse functions, and the graph is reflection, blah, 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 this just tells you that they are a reflection of each other over the line y equals x. Note that the y-axis is the vertical. Oh, you haven't done that yet. Don't worry. Shh, you don't know asymptotes yet. You'll get to that in Algebra 2. So in example 6, we're actually going to find the inverse functions. Oh, this is going to be interesting. A, f of x equals 6 to the x power. The inverse of f of x equals 6 of x is this. We use our formula. So we know g of x. We know the base is 6. So it's log 6 of x. And that should have been a 6. Now the next one, y equals the natural log of x plus 3. We have to find the inverse. Now, I'm not sure how much of the inverse you guys have done in the past. If you're watching this, you're in my junior high class, so you've done none of this. The inverse means this. We write the original function. We then reverse or switch the x and y. So it looks like this. Now, this is where it's weird. You learn that natural log. Okay, so basically, here's what you got to do. You got to get the y by itself. That's what you're doing. So you have to get rid of a times natural log. Now, you haven't learned this yet, but the opposite of multiplying by a natural log is taking e on both sides. So basically, you take an e here, you take an e here, but this just cancels because they're inverse operations of each other. So you have e to the x equals y plus 3. Now we subtract 3 on both sides. You get y equals e to the x power minus 3.